Okay, I'd like to welcome everyone to our virtual 2020 Plus Program Expo. You're in Data Plus Room 3, and we're going to have a presentation from the Predicting Blindness in Duke's Glaucoma population group. We're really proud of the work everybody has done this summer in Data Plus under very extraordinary circumstances. Everyone's done really, really fantastic work. And so we hope you enjoy the presentation. We have Sydney Hunt, Alyssa Shee, and Katika Singh talking about using electronic health records and geospatial data from Durham Neighborhood Compass to predict blindness in glaucoma patients here at Duke. And they can take it away.
Thank you. Yeah, so as we said, my name is Sydney and I worked with Alyssa and Kitika this summer. And our goal was to predict and identify risk factors for glaucoma patients who were presenting to Duke legally blind. And this problem was very important because glaucoma is the leading cause of irreversible blindness in the world. And it can be defined as an optic nerve damage, a disease of the optic nerve that is difficult to diagnose using any one clinical measurement. So we wanted to see what variables were significant. So therefore we combined the EHR data from multiple years, those being 1993 to 2019, and that became our clinical data set. And then we also pulled some variables from the Durham Neighborhood Compass to create a separate data set. And after some data wrangling, we discovered that there were about 33,000 total glaucoma patients, and about 3% of them were blind. And then since there were so many variables, we realized that some of them were very highly correlated, and then this led to some inflated standard errors and limited the results of our model.
Yeah, and then in case of exploratory data analysis, we found that in marital status, the proportion of unmarried people in the blind population increases, and married people in the blind population decreases, which was a new and a strange thing. In patient race, we see that Black or African American people are found to be more prone to risk of blindness, and we also observed that the age is a factor affecting blindness. Older people were more affected by the blindness. In this case, we have the graph which shows density of the age. So these are the scale variables. And in case of macular degeneration, the macular degeneration occurrence can also increase the risk of going blind in patients. So these were some strange conclusions we found using EDA. Next is model selection.
So for our model selection, sorry, can you guys hear me?
Yes.
Hello? Yes, okay, sorry.
Yeah, we can hear you.
I think my internet connection is a bit unstable right now. I don't know, I apologize for that. But in terms of our model selection, we tried two main approaches. The first was lasso and ridge regression models in an attempt to account for multicollinearity. However, this approach eliminated all the variables except for the intercept. And so we wanted to go with a method that was a bit less harsh and something that would be more familiar to clinicians, which would be using univariate models for all variables, and then combining all of those significant variables into a multivariable model. And so that's what we ended up going with for our final model. It's important to note that we didn't use visual field mean deviation as well as the thickness of the retinal nerve fiber layer, because these variables were highly correlated with blindness because they were sort of measuring a patient's vision. And so they weren't necessarily like an underlying cause. And so we created two models, and one model was using all possible clinical and demographic predictors, and another model was using only demographic variables for patient use, because for patients, they might not know their tonometry, for example, but they're going to know their zip code, they're going to know their age, they're going to know their race. And so if we wanted to make something that patients could use, we could only use those variables. Go to the upper right. So here we have the results of our model. This is just a couple of them because obviously it's really small, but our final model is predicted on around 3,000 complete observations. And here we have the most significant variables in the final model. This includes patient race. And so if you are African American, the odds of you presenting blind to Duke is 2.3 times that of a white person. They include marital status, so those who are single are more likely to present blind than married, and we think this might have something to do with age, as maybe more older people are either divorced or widowed, and that leads to them being single. And finally, age, with older people are more likely to present blind to Duke. And down below that, we have the ROC curve of our model, and the AUC of this model is 0.75.
So we were also working on survival analysis to actually see the progression of how the patient can go blind under Duke care. So if the patient was not presented blind when he or she visited Duke care for the first time, we considered them in the cohort, and we saw that if they go blind, how the procedure was and how much time they took to do that. So in this case, the graph shows a Kaplan plot for analysis data set that contains one patient as one observation, and the data frame has clinical features like diabetes and macular degeneration and all other demographic information of the patient. So we plan to use this information to see how the survival analysis goes. But in this plot, using this model, we saw that approximately the survival probability decreases by 20%. So yeah, we are still working on that part. That's it. Thank you. We are open to any questions.
Feel free to enter questions in the chat or raise your hand. I can unmute you.
We also had a Shiny app that was developed. If you want to see, I can share that too.
Yeah, we'd love to see it.
So this is like the final product where from this variables we found that were significant, you can enter their age, and then you can select like all the other factors, and then you enter some other values, and then their zip code you can also change and select, and then this is the likelihood that they are blind. So this is like another part of our final outcome.
That's great. All right, well, I have a couple questions. Like if you had a little bit more time on this project, say another 4 weeks or so, was there something you didn't get a chance to develop that you would have wanted to work on further?
Yeah, I think we would have been working on the survival analysis part. So currently we have one observation as one patient, but we wanted to include a progression of each patient, which will give us more information. And we were taking out a lot of information because we just wanted one observation as one patient. So it'll be great to try that.
Another thing that we were working on, that we considered working on was, so right now all of our data is patient by patient. So every patient has like one measurement, but we actually do have some variables that are available at the eye level, so right eye and left eye. And so one thing that one of our project leads actually suggested to us was trying to predict blindness in an individual eye at the eye level instead of at the patient level.
Wow, yeah, that would be really cool. Definitely. How about the other team members?
Yeah, for something else I would have liked to have done in the future was predicting the confidence interval of that prediction in the Shiny app, just to see a little bit more information on that.
Were there tools that you had to learn this summer that you did not know before Data Plus?
I think,
yeah.
Yeah, I think I learned Tableau and a couple of more functions in R and how to actually deal with big data in R. I mean, a lot of data in R. So yeah.
Mm-hmm. Yeah, I also didn't know how to code in R before Data Plus, so that was a big learning experience.
Alyssa, are you a coder?
No, I have a bit of experience with R, so that wasn't new, but I did learn like some new R packages, some new modeling approaches that I've never learned before, so that was really interesting for me.
Mm-hmm. Has this summer experience affected your planned trajectory or career path at all, do you think, or given you a more solid idea of what you want to do next?
For me personally, I was planning on being a stats major, and after Data Plus, I'm more planning on being a stats major. I really enjoyed this project, and I think we're gonna continue it a bit after. So I'm just really excited to see where this project goes.
Oh, could you tell me more about the work that you're gonna be working on?
Yeah, so I think we're possibly looking into getting this research published, and we're looking at like survival analysis where you know, this is like a pretty short program, but we have to go back into all of our scripts and kind of make sure that what we're doing makes sense at a clinical level, what we're doing works the way that we think it's working, because we actually yesterday just found like a little bit of issues in our code, and that might be like affecting our results. So just like going back and making sure that everything is exactly as it should be before we can consider getting it published.
How about the rest of you? Has that like changed your trajectory at all, or you know, this experience this summer and what you're going to be doing with yourselves next?
Yeah, I think I was planning to get a concentration in health data science in my master's, and I think I still continue to do so. It was definitely a good experience, which added a lot of skills, I guess. So I'll still continue to be going into the health data science trajectory.
Yeah, for me, it just really showed that I was surprisingly interested in data science. I was kind of nervous going into it about how complicated it may be, but my team was super helpful at answering all my questions. So I think in the future I would like to work more with data, and I really enjoyed using the computer science side of it. So I'd like to major in that as well.
That's great. I'd like to welcome anybody else to ask some questions. I know we've got a few other people in this room besides. And we don't have the client in this room either, do we? Yeah, normally I would like to ask the client some questions too about, you know, how they'd like to use this work. Maybe you guys know a little bit more about that, you know, since you're going to continue the project. So will this be a paper that you're going to be working on, or will it be more of a tool, or?
I think the end goal is to make an application which can be used by clinicians, but on the way, if we get some nice results, it'd be good to have a publication too.
That'd be great. Yeah, yeah. Well, great. Is there anything else you'd like to share about your experience this summer?
I really enjoyed it, and I think it worked well, even though it was remote. So I was very satisfied and pleased with my result.
That's great. Yeah, what time zones are you guys all in? I'm just curious.
I am Eastern.
I'm on the West Coast.
I'm also on the West Coast.
Okay. That's not as challenging as some I've heard. I mean, it's a little challenging, but yeah. None of you are in like South Korea or something. That has been an issue for some teams. Good to work with there. Well, I really appreciate your presentation and your work this summer. I think it's been really great. Yeah, if anybody else has any questions, I would encourage you to speak up. Otherwise, we'll go ahead and close this one out. And wait for the next group. Anyone? Okay. Thanks, ladies, so much. You did a good job this summer.
Thank you for helping us in coordinating.
Yeah, you're very welcome. Yeah. Enjoy your little bit of time off before classes start if you're coming back. And thanks again for a great summer. If any questions they think of later, feel free to email me and I will get them to this team. And yeah. All right. Please check out some other groups too while you're here. All right.
Yes.
Bye-bye.